Pluto, a distant and muddled world, was once considered a lone, genuine planet, an individual from our planetary family. However, disturbing enunciations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku brought Pluto back into the spotlight with astonishing transparency. They recommended that this chilly world is on a possible collision course with Neptune. Yet, how could this happen? And what might the outcomes of such a gigantic event be? Are we witnessing a charming, unpredictable scenario? Or is there something more to this approaching, endless disaster? Join us as we explore the possible results of a Pluto-Neptune impact. Pluto, a past planet that was relegated to a more humble status, remains a subject of interest and study in the cosmic community. According to recent findings by leading scientists, Pluto's orbit is perilously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are raising the alarm about a potentially hazardous incident between these two planets, which could pose a significant risk to Earth. But how is such an event even possible? Pluto's orbit around the Sun is not like that of any other planet in our solar system. It takes an astounding 248 years to complete one orbit. This means that since its discovery in 1930, Pluto hasn't even completed one full orbit. However, the intrigue doesn't end there. Pluto's orbit is characterized by its highly elliptical shape, which contrasts with the nearly circular orbits of the larger planets. What makes Pluto's orbit even more fascinating is its inclination, still sitting at 17 degrees to the ecliptic plane. The way Pluto follows its orbit is far more erratic compared to other planets, adding a layer of complexity to its orbital pattern. One of the most interesting features of Pluto's orbit is its intersection with Neptune's. For about 20 years during each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect from their positions in the planetary arrangement. This raises the usual question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influence of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers struggled to explain its peculiar orbit compared to other planets, whose orbits lie close to the ecliptic plane. Pluto's orbit stood out with its steep inclination and unpredictable shape. The mystery surrounding the claim that Pluto's orbit indeed crosses Neptune's is tied to the stability of Pluto's orbit, despite these complexities. The three-body problem in space refers to understanding how three objects, like Pluto, Neptune, and the Sun, move and interact with each other due to gravity. It's akin to predicting where they will go based on where they started and how they pull on each other. In Pluto's case, this problem demonstrates how its orbit, Neptune's orbit, and the Sun's gravity all interact in a complex way. Terms like asymptotic libration, scope libration, and VZK wobbling are part of this issue. According to astrophysicists, what's keeping all planets in their orbits is a kind of libration, particularly between Pluto and Neptune. This term means that whenever Pluto crosses Neptune's orbit, their relative positions are always at least 90 degrees apart. This spatial separation is crucial in preventing their orbits from affecting each other. Libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this suggests that when it gets closest to Neptune or any other giant planet, it is situated far above their orbital plane, providing an extra layer of protection from potential collisions. Another important factor in this situation is the VZK wobbling, named after three researchers, VA, LV, and KU, who studied the movement of objects in space. It describes how three space objects, like Pluto, Neptune, and the Sun, affect each other's movements with their gravity. This interaction helps explain why Pluto's path near the Sun is so unusual. Despite the apparent chaos, this gravitational interaction helps stabilize Pluto's orbit for an exceptionally long time. The VZK wobbling shows that while things in space may seem erratic and unpredictable, certain patterns and rules help maintain order. These factors work together to keep Pluto's orbit stable, ensuring that it doesn't crash into Neptune or veer off course. This three-body problem is essential for understanding how orbits change as a result of gravitational interactions. Focusing on this helps us study Pluto, our neighboring planetary system, and distant stars and planets. Numerical simulations in the late 1980s revealed that despite these stabilizing factors, Pluto's orbit is still chaotic, with minor deviations in initial conditions leading to major differences over long periods. However, these peculiarities of Pluto's orbit have been found to maintain consistency over extremely long stretches of time. Later computer models have helped us understand how the giant planets, like Neptune, Jupiter, and Saturn, impact Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto makes around the Sun, Neptune completes 3. This resonance helps stabilize Pluto's orbit. However, Neptune isn't the only factor. Jupiter's gravity also plays a significant role in protecting Pluto's orbit, and Saturn contributes to this as well. These simulations show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a stable path for an incredibly long time, possibly even billions of years. Perhaps Neptune, Jupiter, and Saturn are working together to make sure Pluto continues on its orbit safely without running into trouble. These anomalies are crucial in the broader context of the universe, helping maintain the stability and consistency of celestial bodies. Without these factors, the solar system, as we know it, might be much different. There would be a position of a lot more noteworthy struggle and insecurity. Bodies like Pluto could, to be sure, crash into others, or on the other hand, be launched out from their steady circles, setting off a flowing impact on other heavenly bodies. For Pluto, especially, with conversations about it conceivably slamming into Neptune later on, understanding its circle is basic. This gives us a more clear picture of the adjoining planetary system's dynamic nature. The instance of Pluto outlines how, indeed, even the most evidently shaky circles can accomplish a state of concordance through the convoluted cooperation of gravitational powers and orbital mechanics. It likewise shows the significance of consistent knowledge and investigation of these quirks to all the more promptly grasp our position in the universe. Investigating the profundities of space frequently drives us to stand up to the eccentric nature of divine bodies, and Pluto's circle is an optimal illustration of this capriciousness. The thought of an orbital resonance, which suggests the touchy reliance of a heavenly body's circle on its underlying circumstances, is clearly illustrated on account of Pluto. This implies that even slight varieties in the little planet's situation or speed can essentially modify its drawn-out circle. Utilizing programmatic experiences has been staggeringly significant for exploration to comprehend how Pluto moves in space. These reenactments utilize complex math to model how Pluto, alongside other space objects like Neptune, pull on one another. By changing little subtleties in the recreations, cosmologists can perceive how even small changes can have a colossal effect in where Pluto winds up. In the last part of the 1980s, these reproductions uncovered something really entrancing about Pluto's circle. Notwithstanding having systems like asymmetric libration and extension libration to keep it stable, its circle can in any case be fiercely capricious. On the off chance that you start with even a minuscule contrast in where Pluto is or how quick it's moving, over numerous years its way could wind up looking altogether different. Regardless of this disorder, Pluto's circle remains stable for billions of years. This recommends that Pluto's excursion around the Sun has a specific request to it, even though it seems tumultuous from the outset, especially when it includes wild circles like Pluto's. This presents gigantic difficulties. The inherent nature of these frameworks suggests that long-term conjectures are frequently loaded up with vulnerabilities. While numerical reenactments give an incredible asset for understanding and anticipating the behavior of divine bodies, they too highlight the restrictions of our forecasts. These models depend intensely on the accuracy of introductory circumstances and the intricacy of the communications they mimic. Any slight misstep or deviation can definitely change results, making precise forecasts an overwhelming undertaking. Additionally, the tempestuous nature of enormous circles like Pluto fills in as a reminder of the ever-evolving and dynamic nature of the universe. While we have made enormous steps in understanding space, the illustration of Pluto reminds us how our comprehension of the universe is still restricted. Understanding the gravitational impacts of the giant planets on Pluto's circle offers valuable bits of knowledge into the more extensive dynamics of the nearby solar system. It shows how the presence and position of every planet can have clearing impacts on the stability and direction of different bodies within the system. So, why are noticeable astrophysicists suddenly raising concerns about an expected impact between Pluto and Neptune? Notwithstanding this multitude of perplexing forces attempting to keep such an event from happening, Neil deGrasse Tyson, a famous astrophysicist, offers a book-length viewpoint on the secrets of our nearby planetary system, especially the charming illustration of Pluto. Tyson, known for his part in the renaming of Pluto from a planet to a dwarf planet, gives clever analysis on the developing nature of divine mechanics and the public's interest in the ignored corners of space. What is happening on Pluto's renaming is illustrated in the ever-growing knowledge of our nearby planetary system. He believes the renaming to be not a diminishment, but rather a necessary change in accordance with our developing comprehension of the many bodies surrounding our Sun. Tyson's approach to divine mechanics is one of ceaseless learning and transformation. He sees the complexities of Pluto's circle as well as its interactions with Neptune from a perspective that acknowledges the unconventionality of space. He suggests that while Pluto's circle is stable for now, it could undergo significant changes in the future. This possibility serves as a reminder of how much we still need to discover about the forces shaping our nearby planetary system. All things considered, Pluto's circle is an exciting case study in the complex interaction of gravitational forces within the nearby planetary system. While its path is stable right now, the baffling elements between Pluto, Neptune, and the other planets suggest that even the most apparently stable orbits could change over time. As astrophysicists like Neil deGrasse Tyson continue to investigate the secrets of the universe, they help us better understand the delicate balance that governs the movements of heavenly bodies. The potential for a Pluto-Neptune impact isn't necessarily inevitable. However, it's an indication of the continually evolving and puzzling nature of the universe. Notwithstanding the established theories surrounding Pluto's orbit, it's important to consider the broader consequences of these forces for how we understand the nearby planetary system and the universe at large. While Pluto's journey is one of intrigue, it's also a reminder that the universe is full of mysteries and complexities waiting to be explored. The thought of orbital resonance, especially between Pluto and Neptune, is a central piece of the riddle. This resonance, where the proportion of Pluto and Neptune's orbits is 2 to 3, is a critical part of divine mechanics. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This ratio ensures that despite their orbits crossing, the 2 planets never impact. This is the result of the gravitational interactions that stabilize their paths, working together to prevent any catastrophic impacts. The significance of resonance in maintaining stability couldn't possibly be more important. It gives an ideal illustration of how systems in space, even those that initially seem turbulent, can self-regulate through subtle gravitational forces. Understanding this resonance also explains why Pluto, notwithstanding its unconventional orbit, has remained stable for billions of years. This balance is a crucial perspective of the nearby planetary system's larger structure. The impacts of planets like Jupiter, Saturn, and even Uranus are fundamental in maintaining stability in the orbits of smaller bodies like Pluto. Jupiter, with its immense gravitational power, acts as a kind of shield for the interplanetary system, influencing the paths of other asteroids and dwarf planets, including Pluto. In fact, some researchers speculate that Jupiter's gravity may have prevented Pluto from being ejected from the nearby planetary system entirely. Without Jupiter's protective influence, Pluto's orbit could have been disrupted even further, potentially sending it out of the